Hello everyone. In this question, it is asked that yc is a function which goes from r to 0, infinity, both open brackets, which is a solution of a given Bernoulli's differential equation dy dx minus y plus y cube equal to 0, and the initial condition is y of 0 equal to c, where c is a positive real number, c greater than 0, and we are to find the limit of yc x as x tends to, sorry, the question is wrong, it should be as limit as x tends to infinity. Okay, fine. So let's start the solution. The Bernoulli's equation is dy dx minus y. Let's take the y cube to the other side, minus y cube. Now let's divide both sides by negative y cube. Okay, so we get minus 1 upon y cube times dy dx, and then minus y divided by minus y cube will be plus 1 upon y square, and minus y cube divided by minus y cube will be plus 1. Okay, so now we are to transform this Bernoulli's differential equation into a linear differential equation. Okay, so let us try a substitution. Let us write u equal to, let's try 1 upon y square. If we try this, if we differentiate both sides, now we get du upon dx will be equal to, this is equal to y raised to the power minus 2. Okay, so it will be, after differentiation, it will be minus 2 y to the power minus 3, right? So it is equal to 2 upon y cube times dy dx. Okay, so in the LHS it is given negative 1 by y cube. So let us divide both sides by plus 2. So it will be half times du dx will be equal to negative 1 upon y cube times dy dx. Okay, so now we can do the substitution. So this is half times du dx plus 1 by y square is u equal to 1. Okay, so now let us multiply both sides by 2 in this equation. After multiplying both sides by 2, we get du dx plus twice u equal to 2, which looks like a linear differential equation of the form du dx plus pu equal to q, right, where p and q are functions of x. Okay, so for our case we get p equal to 2 and q equal to 2. Okay, so the integrating factor if is given by e to the power integration p dx. Okay, so this is e raised to the power 2 dx, which is nothing but e raised to the power 2x. Okay, so the solution of the differential equation, the linear differential equation, this one du dx plus twice u equal to 2, it is given by u times the integrating factor, that is e raised to the power twice x, is integration of q times, what is the integrating factor, e raised to the power twice x dx plus some constant. Now the constant in the question, it is given y0 equal to c. Okay, so we are taking the constant to be something other than c, let's say lambda. Okay, so after simplifying we get u raised to the power u times e raised to the power twice x equal to q is 2 2 into e to the power twice x dx plus lambda. So after solving the integration on the right hand side, we get 2 raised to the 2 times e raised to the power twice x. So integration of e raised to the power twice x is e to the power twice x by 2, right? So by 2 plus lambda. Okay, so this 2 and 2 will get cancelled, and on the right hand side finally we are left with e raised to the power twice x plus lambda. Okay, so if we just find u and divide both sides by e raised to the power twice x, we get 1 plus lambda upon e raised to the power twice x. Okay, so again, u, what is u? The substitution we did here, u is 1 upon y square. Okay, so we have to find finally in terms of y square. We have to find limit y c x as x tends to infinity. Okay, so u is 1 upon y square is 1 plus lambda by e raised to the power twice x. So let us write the right hand side as 1 plus lambda e raised to the power negative twice x. Okay, so now y square will be 1 upon 1 plus lambda e raised to the power minus 2x, right? We've just cross multiplied both sides. 1 by y square was equal to 1 plus lambda e to the power minus twice x, so we have just cross multiplied both sides, and this is y square. Okay, so from here we get y of x. Y is a function of x. In the right hand side we see we have x here, so y is a function of x, so yx will be the square root of 1 is 1, so we can just write the square root in that denominator. 1 plus lambda e raised to the power minus 2x. Okay, so now let's look at the initial condition. Initial condition given is y0 is equal to c, where c is a positive real number. Okay, so using y0 equal to c implies, this implies that when x is 0, value of y is c. Okay, so putting c for x and sorry c for y and 0 for x, we get in the RHS 1 upon square root of 1 plus lambda and e raised to the power, this becomes 0, right? So e to the power 0 is 1, so lambda times 1 is just lambda, so square root 1 plus lambda. Okay, so if we square both sides, we get c square is equal to 1 plus 1 by 1 plus lambda. Okay, so we have to eliminate this lambda. This is a constant we have derived here. We have to eliminate this lambda to get the differential equation in terms of x and y. Okay, so if we reciprocate, if we invert both sides, we get 1 upon c square equal to 1 plus lambda. Okay, so from here lambda is 1 by c square minus 1. Okay, we have just inverted both sides. From here c square equal to 1 upon 1 plus lambda, so 1 by c square will be 1 plus lambda, and then here we have changed the sides. We've taken lambda to left hand side, 1 by c square minus 1. Okay, so let's substitute this value in this equation. Okay, therefore y of x becomes 1 upon square root 1 plus 1 by c square minus 1 times e raised to the power minus twice x. Okay, so this is the function y in terms of x. Okay, so we have to find the limit of y of x as x tends to infinity. Okay, so now we have to find limit of this. as x tends to infinity. Okay, so let us write the expression one more time. 1 plus 1 by c square minus 1 times e raised to the power minus 2x. Okay, so now we have to put the value of x as x tends to infinity in this expression. Okay, so as x tends to infinity, this is e raised to the power minus twice x, right? So as x tends to infinity, basically as x tends to infinity, 2x tends to infinity, right? So e raised to the power minus 2x, it is equal to e raised to the power n negative of some positive number, right? Positive large number. So it is something like e raised to the power negative infinity. Basically not equal to, this tends to. And as e tends to negative infinity, the value becomes, limiting value becomes 0. Okay, so this term becomes 0. So after evaluating the limit, we get 1 upon square root 1 plus this 1 by c square minus 1, and the limiting value as x tends to infinity, limiting value of e raised to the power negative twice x, this becomes 0. Okay, so we are left with 1 upon square root of 1 plus 0. Okay, so this is equal to 1, which is the final answer. Sorry, let us write it in a proper way. So the value is equal to 1. So what are the steps we have done from the beginning? First, this is a Bernoulli equation. So we divided both sides by negative of y cube. Then we did a substitution, taking u equal to 1 upon y square. We converted it to a linear differential equation. Then we found out the integrating factor, then solved the linear differential equation in terms of u. Then we transformed u in terms of y again. After that, we discovered the expression for y in terms of x, function of x, and after that we used the initial condition which was given, and from there we found the value of the constant we used in the integration, lambda, and then reverted back to the original expression we found out for y, and then we computed the limit as was required as x tends to infinity, and the final answer was 1. Okay, so this is it. Thank you.